Right, so today we're going to be talking about for loops, but before we start that, I want to discuss the duck exchange program that I'm going to introduce today. So I'm aware some of you have earned multiple of these plastic ducks, so if you'd like to trade a plastic duck, I will trade you for one of these duck stickers. Okay, so that's the new system. If you want a sticker, give me a duck. You may take one of these with you. They're expensive, so they're nice stickers. So I pay for them myself, so just for you guys. Okay. So we're going to introduce what will be effectively the last imperative control structure that I need to show you. Aside from this, really all that remains for me to do with you is to show you how to do text processing, reading from files, writing to files, and stuff like that. But in terms of control structure, this is going to be the last one. So let's sort of rethink what we've done. So I said we required three things for imperative programming: sequencing, the capacity to order instructions and have the computer go top down and run those instructions. We needed some way of skipping some of the instructions. That was the if statement. We needed some way of repeating some of those instructions. That was the while loop. And this kind of is extra because we're going to need to repeat something maybe an infinite amount of times, but we also need to repeat something a finite number of times. If I wanted to sort of print hello world 10 times, I don't want to have to copy paste that 10 times. So today I'm going to show you a structure for repeating something a finite many times. It is my opinion that for loops are like one of the best language features of Python. It sort of like hides away a lot of details that usually get screwed up, right? So we should be using for loops, right? For loops are really great. Okay. So a loop is a control structure that repeats code that belongs to it. Remember, we use for spacing to indicate belonging. But a for loop is a control structure that, given a group, repeats code for every member of that group in order. So the things that we're going to be able to give for loops are innumerable objects, right? So things that are enumerable are like strings because they have individual characters, lists because we could walk through those lists. Dictionaries are actually going to be enumerable, and eventually, when Caspar comes in and starts teaching object-oriented programming, you will be developing custom iterables. But generally speaking, anything that's an iterable can be walked through with the for loop. It has an exceedingly nice type of syntax that looks like this. So you say for, you use some name as in some variable, and you give it an iterator, and then you have body code that gets repeated. And the nice thing about this for loop is that you're going to have a name which is going to assume the value of each member of your iterator in turn. So here's an example. The sort of most basic iterator is string iteration. This is where we can iterate through a string character by character. We got to sort of put these quotes around characters because we don't really have characters in Python. But something like this is going to print A, B, C, D, right? So I'm going to say for X in A, B, C, D, print X. And that's what's going to happen, right? So nothing too surprising here. But notice the order, right? We did go left to right. There is going to be an order on your iterator, and we're going to walk in the forward direction. The other thing that's very important is that when you run a for loop, a variable gets spun up. In fact, there is a variable now X in memory that's going to maintain the last value that it's holding. So here, X is actually going to be holding D, the last thing that it was equal to. And we can walk through the visualizer if you want. So that's exactly the same example from the slide before. Now we sort of see this box here that we haven't seen before because I'm going to be printing stuff. The output from those prints are going to go to that box. But let's just see. Remember, so a loop, the fun thing about loops is that we can go back up this set of instructions. That's the thing that enabled the looping. So if I hit next here, what you're going to see is that a variable called X has now been given or spun up and given the value A. And then we're going to go back to line 1, and then X is going to maintain the next value, B. And we're going to go back to line 1, and then X is going to maintain the next value, C. And we're going to go back to line 1, and then X is going to maintain the last variable, D. The iterator has then been exhausted. We're going to leave the loop, and X is going to be holding its final looping value, which is sometimes important and certainly something that we may test you on. But this is sort of sneaky, right? This variable X has been sort of defined, but not explicitly by us. Normally, in order to get a variable into this table, we had to say X is equal to something, right? So Python sort of handles that for you. Okay, so what I want to do now is nest for loops because this is something that we haven't done yet, sort of put control structures in control structures. And this is going to be necessary as the sophistication and complexity of our software grows. So here I have two values. I have a string 0, 1, 2 digits and XY alpha characters. Right? That's how we did. Alphas are things that aren't digits, like alphabet characters. I'm going to say 4D in digits and 4A in alphas, print D plus A. So the first question I have is what's the first thing that is printed in this instance? Yes, sir. 0x, right? So let's just walk through this as Python walks through it. So it's going to say, Python's going to look at line 1. It's going to say, oh, into a variable called digits and a variable called alpha, I need to respectively assign the values 0, 1, 2 and xy. At line 2, Python says, I need to assign to a variable d the first member of the thing I'm iterating through, which is 0. And then so this is the thing that is important. The entire loop body gets executed, right? So this is a for loop that's repeating its body. Okay, so it says D gets 0 and then execute this loop. And Python says, sure. So I'm just going to execute another loop. A is going to be assigned X, and I'm going to print 0 plus X, which is 0x. My question is, what is the next thing that gets printed? Yes. 0. Y? Yes, yeah, exactly. 0y, right? Because the loop body gets executed completely at every iteration, right? So this will become exhausted multiple times, right? So we're going to repeat something twice, 3 times, right? So you see that we went 0, 0, 1, 1, 2, 2, right? So the interior loop was doing 2 things. It's exhausting, but also notice that it's resetting, right? A went back to X each time the for loop was executed, right? The thing can go back to the beginning, right? So there's a couple learning objectives from this position. Okay, what I'm going to do now is just move this print statement one tab left, okay? And remember, because Python uses spacing to indicate belonging, you're not really allowed to have empty control structures. So I'm just going to throw in that pass keyword, which is effectively like the null Python statement. This is nothing. It's like a placeholder. So my question is, what will this print now? Well, what's the first thing that prints? Let's start there. Yes, sir. Yes. 0y. All right, so let's investigate what happened here. So at line 1, we assign values to digits and alphas. At line 2, Python says, I need to execute a for loop. So I'm going to start walking through 0, 1, 2, starting at 0. So D gets 0. And then it's going to say, I now need to execute the body of this for loop. But that is just a for loop that walks alphas to the very end. And as I said, when A gets to the end of XY, it's still holding Y. So at this point, D is going to be 0 and A is going to be Y. So that's why we print 0, then Y. Then we go back to line 2. D then goes to the next member of 0, 1, 2, which is 1. This for loop gets exhausted again and ends up holding Y and A. And we print 1Y and then 2Y. Okay? I'm going to move the print statement 1 back again. So 2 questions. How many things are going to print in this case? That's the first question. 1. Okay, and what are we going to print? For a duck. Yes. 2y, right? So there's your duck. I'll put it there. Why is it 2y, right? Because, well, this print statement, does this belong to any of the for loops? No, because it's not at a tab level, right? So it's actually nothing. That print isn't being repeated at all. It's just going to execute once. So the only relevant thing for this example is that the looping variable D and A are just holding on to the very last things that they were assigned, which in this case is a 2 and a Y. Okay, so now I'm going to show you an exceedingly common pattern that we're going to be using when programming, and this is called the accumulator. So we're calling accumulator is just a variable we're going to collect something, typically the answer. So here I'm going to start an accumulator at the empty string, and I'm going to take a variable x. I'm going to walk that through ABC, and I'm going to accumulate on the right hand of the accumulator and print. So what's the first thing that's going to print in this case? Pardon me? A, right? So let's walk through this. So at line 1, the empty string is assigned to accumulator. At line 2, Python says, oh, this is a for loop. I need to execute a for loop. That means I should in turn assign X A, then B, then C, then D. So the first thing that it gets assigned is A. At line 3, accumulator says, oh, accumulator is equal to empty string plus A. Okay, so that's how we get A. What's the next thing that gets printed? B? AB, right? Because we're accumulating, right? So if we then print A and go back here, X says, oh, now I need to be B. Accumulator is equal to A plus B. So that's why we get AB, and then ABC, and then ABCD, right? So as you see, each step we're accumulating something. And this is going to be a very common pattern. Typically, we're going to like have an if statement in this for loop. Like suppose we wanted to exclude all vowels. I could have said at 3, only accumulate if X wasn't one of the vowels, right? So that's the way we could have done that. What happens if I move X to the other side of the accumulator? Instead of doing accumulator plus X, I do X plus accumulator. What effect is this going to have on what is being printed? Okay, so I think A is going to be printed first again. But what's the next thing that's going to be printed? BA, right? Because remember, accumulator at this point, so let's walk through this. So at line 1, accumulator gets assigned empty string. At line 2, X is going to be assigned A. That's the first thing that it's walking through. So at line 3, accumulator is going to be assigned A plus empty string, which is A. Then it's going to print A. Then we're going to go back up here. X is going to be assigned B. Accumulator is going to be equal to B plus A. That's the last thing that the accumulator was equal to. So what we're doing here actually is just accumulating from the left-hand side. And what was the effect of doing this? Well, we reversed the string, didn't we? Right? So this could be a way that we could reverse the string by doing a left accumulation in a for loop. Probably that is how the computer is doing it. Okay, can every for loop be rewritten using a while loop? Do we need the for loop? Who says no? Yes, you are correct that the answer is no. So there's a duck for you. Why is the answer no? Yeah, so think about this way. While loops can repeat something potentially an infinite number of times. Is that adequate to repeat something a finite number of times? Of course. Okay. Yes. Okay, so here I can show you how to swap it out. So if you have 4x and x's, do something with x. We can always write something like this. Start k at 0, that's an index. While k is less than the length of x's, do something with x's at k and accumulate on k. This is a very common pattern in C programming. Which one's better? Yes? The for loop, right? The for loop doesn't require that you have a counting index that you can screw up. It's literally half the number of lines, right? So I never want to see something like, don't use a while loop to walk through iterators. You are not engaging with probably Python's nicest language feature, which is the for loop, right? You cannot throw an index error when enumerating with a for loop. You will probably often throw index errors if trying to loop using whiles, right? So for those of you who are from C, like C does also have a for loop, but the for loops from C are just used for sort of counting. The for loop in Python is a much more robust type of control structure than anything else, right? So do use it. It's like my favorite thing in Python. Converse question, can every while loop be rewritten with only for loops? Yes, sir. No, right? So consider how many times you need to repeat asking for a user for correct input. Like, what should we for loop to? Infinity? Okay. Oh, I had a picture here. I had this picture. Sorry. I don't know why it didn't show up. This guy, right? This meme. Okay. Because every year, someone actually, professor. Okay. So technically speaking, we can trick Python into executing an infinite for loop. But technically, if you look in the depths of the computer, what Python is utilizing is a while loop. So I don't want to see any discussion about this on the EdStem. It's just going to degenerate into semantic chaos. Philosophically speaking, something that is provisioned for repeating something a finite many times cannot be utilized for repeating something an infinite number of times. Though for any of you actually professors, yes, you're technically right, which Homer Simpson said is the best kind of right. Okay, so that's it really for what I have to show you for doing for loops. What I want to do now is just practice using them, right? Because that's how we're going to sort of gain programming competency, not just by looking at things, but by practicing them. So here's the first one that I want to do. Okay, so I want to write a function called remove that given a string, like a character and a string, I want to remove all instances of C from C's, right? So if I want to remove B from Bluey, you'll get Louie. If you want to remove little b from capital Bluey, nothing changes, right? So everyone get what we're doing here? Okay. And you'll see that we're just going to keep repeating the same type of pattern. We're going to accumulate and effectively intervene in that accumulation to include something or not include something, right? So I can say something like define remove. I'm going to take C, that's a string. I'm going to also accept C's. That's also oh, sorry, wrong language, string. And I want to return a string. Okay, so it's something like return C's with all instances of C removed. And a couple usage examples. So remove B from Bluey is going to be Louie. Remove, I don't know, capital V from Verbic is going to give you Arbic, something like that. And I don't know, remove like little a from BBB. That should do nothing. Do we need any preconditions in this setting? Are there any assumptions that we have to make? I think the way that we've stated this, yeah. So remember I said this is a problem kind of that we don't really have characters in Python, right? So basically, I want to ensure the length of C is actually 1. Like I want to remove a single character from a string, but technically nothing's stopping a user from passing in a string and asking for that to be removed from a string. So I'm going to put a precondition saying, no, I want a character. The first input here should be a character. We don't have special typing for that, so that has to be sorted out with a precondition. Okay. So you can see now that I'm just going to execute the accumulation pattern. I'm going to say, okay, we need to accumulate something. What should we start the accumulator at? Well, you can always work this out. Look at what's being returned, and you effectively have to start at the smallest thing of that return type. What's the smallest string? Empty string. Okay, so we're going to start accumulating from empty string. I know eventually I'm going to have to return that. I don't want to do too much, so let's just see if I can actually execute this, if I haven't typed anything wrong. We haven't typed anything in wrong. So what is bare minimum? What do we have to do? If we want to remove a character from a string, what is absolutely required of us? I have a string, I got to remove stuff from it. Don't you think bare minimum, we should have to look at every character of the input string? Okay, so let's do that. I'm going to look at every character of the input string for X and C's, right? Well, for now, let's just sort of print X, and I'll prove to you, oh, sorry. I'll prove to you that we're at least touching every member of that. So I can remove X from blah, right? And you see that we've indeed touched every character of that string. Okay, so all we require now is to sort of accumulate, but only when we want to accumulate, right? So here, if I said accumulator is equal to the accumulator plus X and return the accumulator, this would have effectively no effect. So if I did this to here, right, you just get what's put back. But let's just intervene. And how should I intervene? When should I accumulate? We're trying to remove C from C's. So under what condition should I accumulate? And under what condition should I skip? Yes, sir. If X is not, if X is not in, sorry. What do you mean? We can do this together. So C is the thing that we want to exclude, right? X is the variable we're looking at each of these things. So let's put this. If X is what? What does X have to be in order for us to accumulate? Not equal to C. Okay, I'm going to give you a duck for that effort, right? Because that was very brave of you to try to think in front of the whole class. Do we agree that this is the condition under which we should be skipping? Okay, let's try that. Remove A from AAA. What should we expect back here? Probably I should have put that in as a usage example because it's an edge case. If I remove A from AAA, what should we expect to return? Empty string, right? That's the string where all the A's have been removed. Let's try some of our other examples here. Let's see if we can remove B from Bluey. Let's see if we can remove V from Verbic. Let's see if we can remove, actually ensure that we can remove multiple instances of things. Okay, so we'll remove, that should, yeah, we should still get BBB back. But there you go. Right, so this is a very basic and common pattern where we're going to use a for loop to accumulate an answer and then intervene in that accumulation to do something or sort of not do something. Is there questions from here? I see some sort of concern looks. Do you guys want to ask a clarifying question? Yeah. Yeah. Anyone have a question? Yes, miss. Okay, so that's a good question. What happens if we only want to remove one? What should we do? Yes, sir. Right. We should break out of the loop, right? So here we can just say, okay, so if we want to remove one, we can, oh, this is a little bit more tricky though, because now we require an index so we can include the rest. Okay, so we're going to remind me of this because I'm going to put a pin in it because I'm going to show you something different where we can for loop, but in addition to having X, we also get the list index item. All right, so at that point, we will be able to do it. So please remind me that that was an excellent duck-worthy question, I think. Okay, let's move on. All right. There's the answer. Also, everything that I'm typing onto here is staged for release on Blackboard. It's going to so all of the code you don't have to type in at 4 o'clock. It's going to release. I don't want to release the answers beforehand because then you're going to cheat and win all the ducks, right? So, so you could pay attention to me if you want. Okay, list looping. So lists are also something that are enumerable. That shouldn't be very surprising, right? So I can say X is now equal to this list. And this list sort of alternates between characters and digits, right? A, 2, C, 4, E. For X and X's, if I just print X, you're going to see that X is going to walk through this list in order from left to right and print out everything that it sees. So A, 2, C, 4, E, no surprises there. Here's an exercise. So let's make a function called makeUnique, where you give me a list of integers and I return back a list of integers that are comprised of the unique elements of the input list. All right, so if you give me a list of unique members, then you're going to get back a list of unique members. In the second example here, you can see that 2 has been duplicated a bunch of times, 1 has been duplicated once, right? So they're only going to occur once in the output string. This is sort of like the difference between having a set and between having a list. So let's give this one a go. And we're just going to use the same pattern, right? So def makeUnique. I'm going to give a list of integers as input. We're going to return a list of integers as input. And what we're going to do here, I'm going to say return X's without duplicate elements, something like that. Do we need a precondition here? Is there anything that we require to assume about this list in order to execute this function? Answer can be no. I don't think there's anything that we need the list to be in order to execute this, so I don't think we need a precondition here. We should have a couple of usage examples, so maybe make unique of unique elements will return unique elements. Maybe make unique of something with a bunch of duplicates is just going to return back that. And I'll do another one. Maybe I'll just alternate 1, 2, 3, 4, 5, 4, 3, 2, 1. And we should get back here, I think 1, 2, 3, 4, 5. Those are the unique elements of that. Okay, we're just going to utilize the accumulator pattern again. Okay, so we're going to accumulate. What should we start accumulating from? And I said, look at the return type of the function and just ask what the smallest thing in that function is. So we're returning back a list of integers. What is the smallest list of integers that we can start accumulating from? Empty list. Okay, so eventually we're going to have to return that. All right, so there's an accumulator. Eventually I'm going to return the accumulator. And now, so I'm going to ask the same question and probably get the same answer. In order to remove duplicates from the input list, what is bare minimum required of us? we have to look at every member of that input list, right? So let's just say for x and x's. And do you see how beautiful is this statement? I love the fact that I can write this for x and x's, for student in students, for something in somethings. And it's very idiomatic. It's very readable. Python code should be very readable. So for x and x's, okay, we can say, accumulate. So in this case, when we're accumulating onto a list, what we're doing is appending to the list. Let's just go out and assure that we haven't screwed anything up yet. So I can say make unique, and I expect to get 1, 2, 3 back, right? Because we've just accumulated everything, but this is not yet removing anything. So where should we intervene? Yes. Yeah, so before we append, we should intervene with an if statement of some type. Okay, so what should that intervention look like? When should we accumulate? Yes. Yes, so we're looking at every member of X. We're accumulating an answer. So when should I accumulate? Well, if X is not in the accumulator already, right? If it is in the accumulator, then it's a repeat. We should exclude it, right? So maybe it would be more clear if I said this. If X is in the accumulator, do nothing, right? So that's a pass. Else, we should add it to the accumulator. But would we ever write this in our code? Is this good code styling? No, it's bad code styling, right? Because you never want to have an empty branch of an if statement. Nothing's obligating us to have if-else statements. So what's the prescribed solution for simplifying or refactoring this? Right? Well, if this is what happens when this is violated, you just very simply put a not there, right? And then you don't need two branches. Okay, so let's see if this will work. Can I make unique that? I expect to get 1, 2, 3 back. Perfect. Can I make unique this list? 1 back. Can I make unique that list? I should get 1, 2, 3, 4, 5 back. 1, 2, 3, 4, 5. Any questions regarding this example? It's very, very similar to the previous one we did, and we're going to see this pattern just reoccurring over and over and over again. Okay, let's do more. There's the answer. Okay, so what we just did in this instance actually is called an out of place change. So remember last week we were talking about lists and the various nuances regarding lists. Remember, we're passing around pointers. Did we destroy the input list in any way here? Has X's changed? No. Okay, so this is called an out of place change. It is possible. You may want to say here's X's. Remove all elements from it, and that is called an in-place change. In-place changes are part of the object-oriented paradigm, right? So we're going to learn about that when Casper comes in and starts teaching you about objects, but you should know that there were 2 options here. Destroy X's and remove duplicates from it, or to create a new list and return that one back. In the imperative paradigm, we're usually not doing in-place changes. We're usually returning new things. All right, this is pretty much the philosophy of object-oriented programming, to do in-place changes. But let's not get ahead of ourselves. I just want to make sure you know that there are 2 possible options at this point. Ranges. Okay, so Python's range keyword is used to quickly build an iterator if you actually want a sequence of numbers, right? So I can come here, and if I want to do something like 4x in 1, 2, 3, let's start at 0, like 0, 1, 2, 3, 4, 5, print x's, okay? Because we already had a suggestion where actually we could probably require counting through indexes like this. Okay. We have a special iterator in Python called range. So if I say range 5, you're going to get something maybe unsatisfying. Okay, so I can say for x in range 5, print x, whoops, and it's going to go 0, 1, 2, 3, 3, and 4. If you want to see what's in a range, you can just convert it to a list, but that's a bad idea. The reason that we have this range is because Python is a lazy evaluative system, not an eager one. And this is important. Suppose we wanted to do something really big, like 4x in, 1, 2, 3, but like I want to go all the way out to like a huge, exceedingly huge number. how are we supposed to do that without typing in all of the numbers? Well, okay, we can do that. I can say 4x in range something huge and print it. And it will happily go and do that. But I want to show you something. Okay, so that number is pretty, let's put, it's the 10 with 100 zeros, 10 with 1,000 zeros. This is a lot of numbers, right? So how fast do you think this ought to work? Like building up all of those numbers in memory is going to be really expensive. But if I do this, it's instant. Because what it's doing, it's not actually holding all of the numbers. This is really the essence of iteration. So range, if I say, if I get a range and I make it something huge, what these ranges actually allow for is this calling next. Okay? So it doesn't actually hold all of those numbers in memory. It just knows how to get to the next thing. And if I show you a smaller iterator, something like, we go to 2 and I start nexting on x's, whoops. 0, 1, 2, error. Stop iteration. So this is how Python is walking through stuff. It's building these sort of iterators and walking through them. The only thing that has to be provided to a for loop is this capacity to do next. And in object-oriented programming, you're going to be building custom iterators. But here's the difference. Whereas this happened instantly, if I convert that now to a list, oh, it's like it's refusing. It's too big. It's too big. I'll try to remove some of those. Too large still. How about this? Okay, so 10 with 10 zeros, it technically can fit in memory, but this is my computer thinking. It's trying to put all of these numbers into memory, right? So working with really large numbers, if you want to walk through them, it's sort of silly to store all of those things in memory. That's a little bit wasteful, okay? So it's you don't really need to be engaged. So see, like now I can't actually stop this. So I have to open my activity monitor, or this computer is going to get quite hot. See, there's Python trying to use basically all of my processor to execute that. Okay, now it's stopped. But these ranges are going to be immediate, but they're not going to show you anything inside them. If you want to look inside them, look lists. So here's the generic syntax form for them. So if you want a range, so these square braces you interpret as optional. Okay, so you can optionally give range a starting condition. You must give range a stop condition, and you optionally give it a step condition. This is totally equivalent to list slicing, right? So we've already kind of seen this, right? So range 10, what do we expect to be printed here if I print range 10? Be careful. What will we see? What will the REPL print? Yeah, range 0 to 10. Remember, the right-hand side, as with list slicing, is going to be right exclusive. The type of this is going to be a range. And if you want to see the range, which is not advisable, but is okay if you're sort of doing debugging, right? Then you can see that it's going to give you 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. What numbers are going to be printed here? Right? So I said left inclusive, right exclusive. So what are yes, miss? Yep, 2, 3, 4, 5, 6. Perfect. What about this one? Can we go from 2 to 7, but step by 3? Yeah, so what's the first one? 2, what's the next one? 5, what's the next one? Nothing, right, perfect. There's a duck for you, 2 and 5. Can we walk from 2 to 7 backwards? No, we can't. So what do we expect to be returned here? In this case, it returns empty. There's nothing in it, right? It tried, but there's no step that it could actually make. Can we go from 7 to 2 walking backwards? Yes. Okay, so what is the first thing that in the list? What's the last thing in the list? 3, right? Right exclusive. It gets a little bit tricky because we're sort of walking in the opposite direction. Okay, so if we want to walk through a list and have indexes, which was required for my colleague's question down there, you could do something like this, right? So I can have a list 11, 22, 33, 44. And instead of saying for x in x's, I can say, oh, for k in range length x's, do something with x's at k, right? And This is why ranges and list slicing are set up deliberately to be right exclusive, right? Because this is already handling the fact that we're zero indexing by excluding the length of the list. Otherwise, we'd have to put a -1 there. Okay. So despite this existing, this isn't the best way of getting list indexes while also traversing a list. Enumerate is the way that you want to do this. This is a very, again, this is another thing that I love from the Python's tool set. And it sort of works like this. You give enumerate a list, and enumerate returns back to you a list, but technically speaking, an iterator. And the list is comprised of tuples. And the tuples are the list items where the first element is the list index. Right. So in this case, if you enumerate over, x naught through xn, you're going to get a list back that's 0x naught all the way up to xn. So we can just investigate this a bit. Right. So I can say, here's x's. Yes, ducks. Okay. And I can enumerate through ducks. Whoops, what is happening? We have x's, it's ducks. I can enumerate through x's, and we get something perhaps a little bit unsatisfying. It's saying, I am an iterator. I am ready to be for walkthrough. Okay. But if we want to actually see what's in it, right, perhaps we're debugging what is happening with my REPL. Sorry, guys. There's x's. There's enumerate x's. I want to maybe convert. Okay. Sorry. Something is really screwy. Let me exit this. Let me go back in. X's is, Jesus, Murphy. X's is ducks. Okay, I'm going to say enumerate far out. Okay, just going to close this. Give me a second. All right. I don't want history. I want you to be destroyed. Try that again. Okay. X's is, oh, Lord. Oh, this is going to be a great lecture today. X's is, what is, can you see this? Hold on. Chat, can you see this, the new REPL? Yes, okay, perfect, okay. Okay, X's is ducks. I'm going to enumerate through X's. We get that unsatisfying object, but if I want to sort of put a list over that so we can see what's inside of it, you get something that looks like that, right? So I can do something like for kx in enumerate through x's, and maybe I want to print something structured. I can say print maybe this structured string. I can say something like x's at k is equal to x. So k is equal to x, and there you go. Right, so this is a way that you could walk through a string while also having the list indexes. Okay, so let's return to the question that was posed from before. That is, suppose we want to just remove the first element of a... Okay, hold on. I really would like to fix this. Okay, let's do this. Define, I'm going to call this foo. I'm going to say x is a string. X is a... And sorry. C is a string. C is also a string. I want to return a string. Return C's with the first instance of C removed. Okay, so something like if we have foo, I want to remove the first instance of X from A, B, C, X, A, and X. We're going to get back something like A, B, C, A, and X, okay? And maybe another one, I want to remove the first instance of B from, and we got to be sort of clever in our use cases. So I'll say Bob, B from Bob, right? That should be this, but we should also make sure we can, so that removes it from the first one. We should also make sure that we're capable of removing it from the last one. So let's see, can remove B from here. That should be AO. Okay, so I don't know. I haven't coded this ahead of time, which is usually spells disaster, but I'm feeling a little bit courageous today. Let's try. Okay, so I know that I need to accumulate on a string. That's what the answer is. right? So I'm going to start with the smallest string, which is the empty string. Eventually, I need to return it. I know bare minimum I'm going to have to walk through this list, but in this case, I do want to actually have the list indexes with me. So for kx and enumerate c's, we're going to have x, a character of c, and k, its list index. Okay, so I want to, I want to accumulate. So we're accumulating. Accumulator is equal to accumulator plus x. Okay, but I don't want to do this. Yeah, I don't want to do this if x is c's. Okay, so if x is not equal to c, then go ahead and accumulate it. If it is equal to c, then what should we do? I want to remove it, right? I know that the accumulator, I know that I'm at list index k. So what I want to do now is include everything else. How can I get the rest of the string starting at k? What tools? So this, okay, we don't have many tools at our disposal. Maybe like 6 of them I've taught you. What tool on strings do we have that can extract partial strings out of that? String slicing. Absolutely. Duck-worthy. Okay. So here what I want to basically say, well, the accumulator should accumulate the rest of C's, right? From k plus 1, because I want to exclude k. That's where I'm at currently. And then I can return that. Let's see if that works. Sandbox. Okay, let's see. Can I remove, does this work? Did that work? Yes, that first X is gone. Does this one work? No. Okay, so I screwed something up. See, this is clever. This is me programming in real life and screwing up and debugging. This actually is pretty good for you to see. There's a mistake in this code. I don't know what it is. What's the mistake? Can anyone see? Why is there an O there? Pardon me? Oh, we kept looping. We kept looping. That's wrong. I need to short circuit out of this. We're done. We're done. Nothing else to do. Perfect. Okay, so here I should say unreachable, right? So because either you can short circuit with the return, or you can, the alternative to that was using a break and then a return. I think docs are always worthy of debugging. So there you go, sir. Let's see if this works. Can I remove B from Bob? Perfect. And now let's see if you can remove it from the end. Okay, that's wrong too, right? So, but like I've picked good testing examples, right? Because it's uncovering problems. Yes, sir. Oh, zoom in. Yeah, no problem. No problem. Okay, so what other mistakes are we making here? Oh, yes. Yes. So so in this case, we only return if the character exists in the string, right? So I should actually put this here, perhaps, put a break here instead. I don't know if that's going to fix it. That worked. Okay, so can I remove, I actually wanted this. Let's see if that will work. Great. That was a really important thing that you just saw. You just witnessed me program from scratch and make several mistakes and error recover. This is live coding. It's actually a pretty effective way of teaching. The other thing that you should learn is that I chose these test cases wisely. I made sure that I could remove something from the beginning. I made sure that I could remove something from the end. There's probably one more case that I should have included. Can anyone think of it? This time for a sticker. Pardon me? No, not quite that one. I think, yes, sir, in the back. Oh, yeah, probably I should have had ones that repeat second time, but that one's here. When it's not there. I had no example for trying to remove a character from a string if that character wasn't in there. So there's a sticker. Let's add that one. So something like foo, can I remove X from YYY? And here we would expect nothing to happen. Okay, great, great. See, even very basic pieces of code can be screwed up if you're not giving it enough detail, but I screw up details. So don't feel bad when you screw up details. There's no programmer on this planet, except maybe for Steve Wozniak, who can program things perfectly the first time around. I don't even usually write into the computer the first time around. Usually I write it onto paper the first time around. Because it slows down your thinking. Like being able to type very quickly actually is bad. You want to do slower type of thing. Okay, thank you for that, class. That was really informative. Okay, so here's just some examples for using that enumerator. Remember, this is the tool that enables us to walk through anything, grabbing list indexes as well as the item itself. So if we want to enumerate through science ac labore, we're going to get 0 scienza, 1 ac 2 labore. And this also happens to be UQ's motto, by means of knowledge and hard work. Yes, sir.
Instead of using tracking method index.
Yeah.
So is there like a condition?
Is there excuse me, a bit condition? Oh, so I can never answer these questions because you get to choose whatever one your preference is, right? So I sort of have the analogy here, like imagine that I was like teaching you how to paint stuff, and I'm painting a horse. And you guys are like, why did you start with the tail? I'm like, I don't know, because I wanted to. Why didn't you start with the tongue? I don't know, because I didn't, right? So I can't really give you a prescription of how to code. What I'm trying to do is to show you the tools that are available to you, how to use them, what the pitfalls are. But I do encourage you to find your own style. I have a style. Other people have differences. You will find your own style. Okay. Dictionary looping. So we also learned last week about the dictionary. This is the data control structure. This was the not control structure. The word escapes me now. But this is what we needed in order to solve the problem. How could we return a frequency report of a word? Right? We determined that our tools were inadequate. So a dictionary is like a list, except that we can index that list not only by numbers, but by anything that's what? What are allowed to be the keys of a dictionary? Immutable types. Mutable types cannot be keyed in dictionaries. So can someone give me an example of something that can be a key in a dictionary? Strings. Someone give me an example of something that cannot be an item in a dictionary. Lists. That is definitely one of the multiple choice questions on your intercept. 100%. I've already submitted it, right? So keep an eye out for that one. It's like something like, here's a bunch of attempts of keying into a dictionary. Which one will error? And it's the one which is trying to key a list. You're welcome. Like, okay, so a for loop will iterate through. So, okay, so the problem is now a dictionary is comprised of items, right? And the items are sort of these key value pairings. So the relevant thing about walking through a dictionary is that when you for loop through it, the thing that you're going to grab are keys. Okay, so the master pattern for a dictionary is like this: for key in table. You can sort of then say the value is equal to the table at the key, right? You can say table, you can say dictionary, you can say hash table. These things are all sort of equivalent. But remember, when we're iterating through a dictionary, which is an iterator, the thing that you are getting are keys. Okay, so here's an example. Okay, so here's a hash table or dictionary or table that maps red to 1, blue to 2, green to 3. And if I have this for loop that says for key in H and I print out the keys, you're going to get red, you're going to get blue, you're going to get green. You're not necessarily going to get the same order. Why is that? Up till now, I'm saying there's a predictable order. We're going left to right. What isn't true about dictionaries? Yes. Yeah, dictionaries don't have ordering. That's why we're using these curly braces, right? So don't assume the order if in your logical control flow, because it's not necessarily going to walk through it the same way that it's displaying. The only guarantee that you're going to get is it eventually will touch every key, and it will touch every key exactly once, right? So, but don't utilize the ordering in your logic, because it won't work, and you're going to get a really hard bug to track down. So if that's how we can walk the keys, if you want to walk the values, you simply just then have to sort of retrieve that value from the hash table by using the square brackets. So here for key in H, if I print H at key, you're going to get 1, 2, 3. Okay, so let's just do a bunch of examples to see if that we can utilize this. So here's one. And this is the thing that we did last week, remember? Return a dictionary mapping the characters of x's to the number of times that they occur in x's. This is exactly the character frequency problem that I said we needed to put a pin in because I needed the for loop in order to do it. So let's do it now. All right, so def, what did I call it? Character index. So what I'm going to get is I'm going to input a string. So C's is what I usually call it for characters. And what I want to do is return a dictionary, and the dictionary is going to be mapping strings, but really characters, sorry, strings, to integers, their number of occurrences. So something like return a frequency dictionary of the characters of C's, something like this. So I can say maybe character index of A, B, 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 C, 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 C. That's pretty long. Oh, okay, who cares? It's going to be something like A maps to 2, big A maps to, I think I need a better, let's just add some arbitrary things here. Okay. A goes to 2, big A goes to 1, little b goes to 2, big B goes to 3, little c goes to 2, big C goes to 2, and x goes to 1. And we're going to code this up in a couple of different ways. Okay, what's the master pattern? Start with an accumulator, for loop through, and accumulate in that for loop. Okay, so here's the accumulator. We're eventually going to have to return that accumulator. What should we start accumulating from? Remember, I said, look at the return type and ask what the smallest thing in the return type is. So what's our return type? Dictionary. What's the smallest dictionary? Empty dictionary, a dictionary with nothing in it. So that's an empty dictionary, but this is also an empty dictionary. Turns out this is faster, right? But it doesn't really matter at our stage, right? So either one's equivalent, but why not start using good practices now? It's better to do this one. Okay, so I'm thinking, so bare minimum, if I want a character frequency, bare minimum, I have to look at every character in this string. So what do I need to do now? A little bit more sophisticated type of if statement intervention. What do I need to do? Yeah. Okay, so like think about this. We're accumulating. At this point, suppose we're at the first iteration. Is there anything in the dictionary at all? No. Okay, so if any attempt to index into that dictionary is going to throw a key error because nothing exists. So we got to be pretty careful now, right? So here I want to say basically, like what I'd want to do here effectively is say, okay, go into the accumulator, go to the, find the key for C and increment this by 1. Okay, that's what I want to do. But if I put this is certainly going to error, right? Because nothing, this is retrieving. I'm trying to retrieve something. And if nothing's there, right, then we're going to throw a key error. So I'm going to show you how to resolve this in 2 ways. The first way is this. You first ask if the key is available to you. Okay, so if C is a key in the dictionary, then it's okay to do this. Otherwise, what should we do? Yeah, we got to put it in the dictionary. So how can we do that? So into our accumulator dictionary, at the key for C, what should I put there? 1, right? Because we need to count it once. Is there anything evidently wrong with this program? I don't think so. Let's give it a try. Character index of this. Maybe this. Okay, let's try another one. Character index Drake is overrated. My favorite example. Okay, see there, I have another character dictionary. Okay, so that's one way that we could have resolved this. What's another way that we could resolve this? That's kind of a bad question. Okay, here's another way that we can do this. Before entering this for loop, okay, I'm gonna revert. Okay, so here's another peril. So I wrote it like this very deliberately. So the key retrieval was super evident. But sometimes you would write it like this, in which case the key retrieval is like kind of hidden, right? So be careful of that peril. In order to do this, the accumulator at C has to exist. even though there's nothing like physically present showing you that you're doing it from that. But nonetheless, I can still do it this way if I want, if I first go through C's and simply assign a default value to every member for that dictionary. So now that will still work, right? Because the keys exist immediately, right? This may be a little bit inefficient because we're touching characters multiple times and doing overwrites. But those were your two options. You can assign everything a default value at first, or you can use an if statement to basically ask if the key exists before you try and key into it. Okay. So for loops enable us to iterate through anything iterable. Strictly speaking, they are not necessary. To repeat something k times, we can just copy paste k times using a while loop, but we use them a lot, right? So I want you to be utilizing the for loop. You should never be utilizing a while loop to walk through something by indexing. That is a C-style way of doing things. It is error prone. It is ugly. Let's use the beautiful for loop. This is a very, very nice language feature. Okay, what's next? Not quite. Here, comprehensions. Okay, so this used to be in the advanced part of this course, but I think it's too useful to not show you because it will really really have a significant impact on the size of your code. And when I was working at the University of Toronto, we were teaching this to first year classes, and it's fine. So this is something that I really like. It's borrowing from the functional programming paradigm, and it's also a very cool type of sort of language feature not available in all languages. So I'm just going to refresh my coffee. Oh, because I love it. I just bought tickets to the Wiggles. That's going to be fun come December. I didn't know who they were because I'm from Canada, but now I'm deeply engaged with them. Tree of Life is my favorite thing ever. That guy is awesome. Any of you people from over the ocean like me, look up sorry, not Tree of Life, Tree of Wisdom. Tree of Wisdom. Yeah, he's pretty cool. He's very energetic. Okay, comprehensions. List comprehension. So this is going to be a way that we can rapidly generate iterators, not using for loops in one line. And we're borrowing this from mathematics. So some of you should already be familiar with something called set comprehension or set builder notation. Do any of those terms land with anyone? Perfect. Okay, so in any case, maybe eventually you'll see something like this. So in math, we have a way of generating sets. And I can say, oh, this is the set k squared, such that k is taken from the set 0, 1, 2, 3. And that's how you could get 0, 1, 4, 9. We can also utilize it in summations. I can say, oh, sum k squared for k taken from 0, 1, 2, 3. And we get, 0 squared plus 1 squared plus 2 squared plus 3 squared. Both of these are naturally been provisioned in Python. They're part of the language set, right? You don't have to introduce anything. So I can say something down here, k squared for k in range 4, and it's going to return the list 1, 0, 1, 4, 9. Here I can say sum k squared for k in range 4, you're going to get back 14. It's basically the analog of the thing that you're seeing on top from math. You can also do dictionary comprehensions, right? So anything iterable you can comprehend here. So here I can say x maps to a formatted string. Value is x for x in range 3. So I'm going to get 0 to value is 0, 1. Value 1 to 2. Value is 2 is 2. I can already show you that it would have simplified this already, right? Because now, instead of starting from an empty dictionary, I could have started from this. X to 0 for X in C's. That builds the default dictionary with all of the default values that you require with one line. And I can show you, yeah, we're still working, right? So it's a way that you can actually just eliminate requiring a for loop to do something very rapidly on one line. It's sort of leaning into this fact that we accumulate a lot using a for loop, and it allows you to sort of, do it a little bit more compactly. Okay, so there you go. 0 to x goes to 0 for x in A, B, and C. As I said, very useful for defining default values. I can say C is equal to hello world. And here's the one-line solution for the character frequency problem. I can tell you that there's a string method called count, And I can say X goes to C's dot count X for X and C's. And there you go. There's your frequency dictionary, right? Instead of requiring all of that work, you can have done it in just sort of one line, right? And this is sort of what functional programming is. All the programs just end up being one line because we're doing stuff like this. You can use multiple for loops in one of these list comprehensions because of course we could have multiple for loops while we're accumulating. The relevant thing here is to know how they are exhausting. So the way that they're exhausting is in the same, if you were to write these for loops like regularly, the first for loop is the top one, then this one is the one inside, and so on and so forth, right? So this gets exhausted many times and this gets exhausted like fewer times, right? So I'll show you what comes out of here, right? So it's relevant here. That's A, right? So 0, 1, 0, B, A, B, B, C, C, right? So this is exhausting last, right? So this is the top for loop. This is the for loop inside. If I swap them, right, I've just taken that and swapped them. Now you can see we get 0, 0, 0, 1, 1, 1, right? Now the order has been permuted, right? So here it is strictly speaking. If I say X's and I have AX for A and ABC for X in range 2, this is totally equivalent to the following 4 lines of code, which is why we want to show you this. I'm showing you this because you can replace 4 lines of your code with 1 line of code. And less lines of code is better, less to maintain, less places to make mistakes. Okay, so let's just start off easy. Let's write a function that disassembles a string into a list of characters comprising the string. This is sometimes useful, right? Because strings are immutable. So if we wanted to do something like remove things, it may be helpful to sort of disassemble everything into a list, which is mutable, all right? So let's try that. Whoops. Def dis, I'll just say dis. I'm going to spell it wrong and everyone will laugh at me. Let's just close this. We don't need it anymore. Okay, so I'm going to give C's, which is a string, and I'm going to return a list of strings, but really characters. It's going to be something like disassemble. Paul is going to return something like P, A, U, L. Okay, so I'm going to do it with an accumulator first, right? So we could accumulate from an empty list, have a for loop running through that string, and I could accumulate like that. Like that would work. Nope, not food, this. Yeah. Right? But as I said, those 4 lines can be replaced by 1 line. What line is that replaceable by? Anyone? And I'll show you because we're new. And it's X for X in C's. Right? That's the identical. That's basically the short form for the accumulator that I just wrote. So I can show you here. We get the same thing back, right? So this is effectively the most basic an accumulator can ever be. Well, I suppose I could do something like X for J in range 6, right? Just to repeat that a bunch of times if I wanted. But yeah, there's nothing more basic than that. All right. So there it is with a for loop, right? And there it is with the comprehension, which is like 1 line of code instead of 4 lines of code. Write a function which checks if a string has strictly more capitals than lowercase letters, ignoring all other characters. Now, I've given you a new tool. I've given you list comprehensions, and I've given you summing. Can we use the new tool to solve this question? Okay, let's do it in 2 ways, right? So we're going to do it the first way. I'll just call it, what did I call this? More capitals? Fine. More caps in C's. Okay, so this is going to return bool. So return true only when C's has, I'll say strictly more capitals than lowercase letters. All right. Okay, so I look at this and I start thinking, okay, I'm going to need to know how to detect uppercase characters. I'm going to need to know how to detect lowercase characters. I'm going to have to count stuff, right? So let's see. I know I need to start counting things. So let's say these are the uppercase ones. These are the lowercase ones. we'll start counting them from 0. I need to do something like look at every character in this string, and then and this is something I'm going to call wish list programming. I'm just going to say if is capital X, right? Then you can increment upper. If is low X, then go ahead and increment low. And then at the end of this procedure, just return is upper strictly greater than low. Okay, why is this called wish list programming? Well, I'm programming as if functions exist already that I require, but now I just go ahead and implement the things that I need, knowing the tools that are going to fix this. Yes. I guess technically, yeah. Like pseudocode is just a description for writing. Like pseudocode would more so be like something like this. Uh, for every letter in C, if C is capital, right? Increase counter or something, like using English descriptions, right? It's like kind of a halfway step towards writing the program. The thing about Python that people joke about is it's so idiomatic, so English described that people say it's like executable pseudocode, right? We wouldn't get stuff looking this nice in Python, but the fact that you could basically read this like English, like for X in C's, if X is a capital, then incremented. If X is a lowercase character, then incremented is nice. Your code should be readable. You should strive for that type of clarity. You don't get access to this type of clarity, well, if you're choosing poor function names, right? If this was like F, this was like G, suddenly all of the descriptive nature of the program starts to evaporate. Or if you're using a lower level language where we do have to be quite aware of like indexing and not falling out of indexing, we're more in the weeds. This is why this is kind of a nice programming language to be learning in, because some of that dirtier stuff is automated. In any case, let's go ahead and write capitals. How can we implement is cap, right? I'll just write one thing here. Is cap. X is, I guess, false. Is cap of capital X is true. Is cap of like a numeral, I guess, is going to be false. And I guess we do need some type of, okay, so return true only when X is a capital character. And then we do need a precondition, right? Because remember, we don't have characters, technically speaking, in Python. So I need to insist that the length of X is equal to 1, right? To basically enforce the fact that it's a character. This is a string. It returns a bool. Okay. So all of that decorations for a lot of stuff. I guess I could just duplicate this. I'll just throw a return statement in there. I can duplicate this for is low. And then I just need to swap these things. Okay. Okay, so again, I've given you not many tools. Which tools are available to us that can help us detect if a string is a capital or not? ASCII. Okay, that's a good start. Okay, so we know that all of the characters are listed in a table and they're all numbered. How can that help us? Yes, miss? Sure. Yeah, okay. But how can we compare strings? Yeah, was it the case that we could say like, hey, is A less than Z? What's true about a capital character? It's a capital character has to be bigger than or equal to A and less than or equal to Z. Oh, that's one way of doing it. I probably qualify that as the best way of doing it. So here I can say return is X, is this bigger than or equal to capital A or less than or equal to capital Z? Here's another dirty solution that technically works and would be kind of fine. Is X in... Okay, I don't want to type it, but you get my drift. Or you could just write all the capital characters and you're off to the races. But I think I like this one the best. Okay, we can just reutilize this down here. I'll just change this to a lowercase a, this to a lowercase z. I think I did that right. Whoops. Let's just go out and see if that's working. Can I get, is cap true? Is cap this? I would make jokes about no cap and stuff like that, but I have no idea what these Gen Z terms mean, so I just make a fool of myself. But their option was there. Okay, that seems to be working. Let's repeat this with is low. This should be true. That should be false. Is low of a capital should be false as well. Okay, so that seems we're off to the races. Let's see now. So this technically now has been implemented. So let's see what we can do here. Can I say more? Is there more capitals in this? Right. So there's no lowercase characters. So this better be true. True. If I take them all out, if there is no uppercase characters, that better be false. Okay. So there's 4 lowercase characters here. I'm going to intersperse them with 5 capital X's. This better be true. If I remove one of the X's, that better be false because I said strictly. Seems to be working. Okay, but we haven't utilized the new tool. I just built an accumulator like we did in the first part of class. There is a very clever way that we can utilize a bunch of stuff that we learned in Python to make this a one-line solution. I promise you, and you'll understand it. Is there any ideas here? Okay, so I'm going to try to lead you to discover this one-line solution. Okay, so here's a list comprehension. I'm just going to put something in here. Okay. Drake is overrated. Okay. I'm going to build a list comprehension. I'm going to say is low X for X in X's. Okay, so now we have a list, which is basically reporting true, false if each of those things are, capital or not. Does anyone see the solution yet? Is there any way to count the numbers of trues in here? Okay, I'm going to remind you of more things that we learned about Python. I'll try a smaller example. X is AAA. Here's a list comprehension through that. And I'm going to show you something. What will this equal? 2. Anyone see the answer yet? What happens instead of doing a list comprehension, I do this? What is that a count of? The number of lowercase characters in the string. What is that? What did I call the other one? Oh, cap. Okay. That's low is cap. Is that not a count of the uppercase characters in the string? Okay, so let's go down here. And I'm going to do a couple of refactors. So I'm just going to say return sum is cap X for X in X's. That has to be bigger than, C's. Actually, I'm just going to change that to C's. That has to be bigger than, I'm just going to break this over 2 lines by using redundant brackets. Sum is low X for X in C's. Let's see if that works. More caps in here. True. More caps in here. False. More caps in here. True. More caps in here. False. But actually, I didn't really need to do this. Like this could have been a less than or equal to X, less than or equal to Z. This could have been less than or equal to lowercase a, less than or equal to uppercase Z. And we still get, oops. Not a, X. And we still get all of the lovely functionality in one line of smart Python code. Okay, so that's it. You don't have to do this, but I think I would like to make it available to people who want to use it because there's a bunch of other great ways that we can utilize this. Okay, so that's that. Okay, so also in the system, let's try to build all and every. As some of you are taking 1061 or have taken 1061, you've seen this funny upside down arrow and backwards E. This has utility for us too. Like we want to be able to ask questions like, hey, is there any lowercase character in this string? Is there any odd character in this list? Is every character in this list uppercase? Right? And here, having all and having any is going to be of great utility. So given the tricks that I just shown you, I want to write a function all. All right, def all. I'm gonna my all. All's already in the system. That's the sort of punchline here. So I'll just call this my all. I'm going to give it a list, and I'm going to return back a bool. And I'm going to say return true when all members of X's are truthy. Okay? I'm going to return. And I want another one, definition my any X's list bool. It's sort of like return true when any member of X's is truthy. Okay, so something like, I can say my all, sort of say 1, 2, 3. That should be true because everything is true in there. My all 1, 0, 3 is false. Right, my all Paul is true. Okay. For any, our examples are like this. If I have my any, I can say 0, 0, 0. There's all of those are false, so that's false. But if my any 0, 2, 0 should be true because 2 is truthy. So there does exist a true value in that list. Okay, so we probably could easily do this by just for looping through it and short circuiting or accumulating, but I want to use the new tools at our disposal. So how can we utilize our new tools and stuff that I've taught you to solve this question? So I just showed you that we could sum over true false. Right? So if I do something like this, I want to sum X for X in X's. I'm going to convert this to a bool. So everything coming out is going to be true or false. If every member of that list was truthy, what should this sum be equal to? Yes, the length of the list. Does that make sense? Right? Because this list is of length 3. And if something counts as 1, it's true. And if something's not true, it will count as 0. So the only way for every member of that list to be true is for if I switch everything with true with 1 and everything false with 0 and I add them up, that should be equal to the length of the list. What should be true of the sum for any? If there is at least 1. Yes. Bigger than 0. Perfect. Okay. All right, so now I can say something like, are any of these values not are false? That's going to be false. If I put this in here, that's going to be true. If I can do something like, any of these members true? Yeah, they're all true. Oh, sorry, I'm using the inbuilt ones. I need to say my any, and I need to say my all. Okay. But that's sort of the point, right? We have implemented all and any, but they actually already exist in Python for you to use, and you should use them. They're quite useful. And here's some use cases for them. I can say, is every letter a capital? I can say, is it all the case that X's are between capital A and capital A and lowercase z? I can say, is any letter a capital? I can say, is any letter between A and Z for X and X's? These go really nicely in if statements. You can say something like, if any member of this list is an uppercase character, do the following. That reads really, really nicely. So do make sure that you're sort of utilizing these any and alls when you want to. Okay. The elements of a list comprehension can be filtered. There's one extra thing that we can do with list comprehension. So not only, we can also the capacity to do this if intervention is built into the comprehensions as well. So I can say X for X in range 101. That's going to be all the numbers 0 through 100. If, and this is going to be the condition to keep it. Right? So if I want to accumulate all the numbers less than 100 that are both divisible by 3 and 7, I need to ask if X mod 3 is 0. That's why I have to not it. Remember, doing a 0 check in Python, you don't say X is equal to 0. You say if not X. I don't like it either, right? But that's sort of like how the Python style guiding requires us to do it. But you can just read this if as you want as if x mod 3 is equal to 0, if x mod 7 is equal to 0. Those are the conditions under which it is divisible by 3 and by 7, right? So you can always put a condition here to filter out the results. But in this case, this is the condition for including, right? So here you'll generate 0, 21, 42, 63, 84 if you want. And I'll show you a little bonus thing because I think this class is a little bit more clued in than some of my previous classes. So I can say x for x in range 10 if not x mod 2, right? So this is going to give us all of the even ones. But I said sometimes if we want to make this really big, then this is going to struggle. Okay, so here's a little secret. This is the first time I've ever told this to a 1001 class. If you use rounded braces here instead, you get a generator instead of a list. And then you can go ahead and for loop through that. So if you see, I can just, oops. I can say for x in these circle braces, x in range 100, if not x mod, if not x mod 2, whoops. Oh, sorry. So I have to, this is going to be a little bit weird. Okay. So for x in range, it's sort of like a double thing, but just for illustrative purposes, print x, right? I've printed all of the numbers, right? Even numbers. And I could have put an arbitrarily large number in there and it's fine. So I'll never test you on this. This is just for people who care to know that you can actually use rounded braces for these list comprehensions to generate generators instead of lists. Okay, so the general pattern for a list comprehension is this. There's no way to have multiple filtering conditions, but why isn't that a problem? Yes, sir. Yeah, just keep using and, right? You don't need a way to define multiple p's. You can just stick a conjunction in it. I already did that, right? I said x mod 5 and this, and this, and this, right? So you only get one if predicate, but that predicate can be of arbitrary sophistication, right? Because you have conjunctions and disjunctions available to you. So they can always be as sophisticated as you want. So the general pattern is here. You could say x for x and x's if px, or x for x and x's for y and y's if pxy, x for x and x's for y and y's for z and z's, and you can do as many of them as you want. The only relevant thing that you need to remember is that the for loops are written in the same way that you would encounter them if you were writing them as embedded, right? The top down. Okay, so comprehensions are a rapid way of forming lists and dictionaries that would otherwise require accumulation with for loop. Okay, so the next thing I want to do is tons of practice. And there's two options now that we can do. I can solve everything for you and we can do it together, or I can show you it. We can break for 5 minutes so that you can try to solve it before we come back. Which would you rather do? Not all at once. You want to do the second? You guys want to give it a go yourself? Okay, so we'll do that. Here's the first one. Let's see. Okay, perfect. Write a function that capitalizes every character of a string. Don't use a list method. You have to use your brain. Use your brain. 5 minutes. And I'm going to, for the sake of the recording, I'm going to hit pause. But one person, there has to be one person in here who reminds me to unpause this because this is always very dangerous. So see you in 5 minutes, YouTube. This should be instantaneous. Okay, 5 minutes. Write a function that capitalizes every member of a string. Go crazy. For loops should be required. You need to accumulate something. Some intervention is required. Same pattern each time. Take 5 minutes. Oh. go ahead and raise your hand if you finish, and if enough hands go up, then we'll continue. No, you are only allowed to use tools that you've been given, because obviously there's a list method that does this, but I've asked that out. And so for those of you who know what list methods are, for strings, like there's literally, so you can just say dot capitalize and it will do so. Oh, maybe upper. Okay, upper. But then if on an exam I say, how is this implemented? Then you have to. So once you get objects, then this. But try to use only the tools I gave you, because like there's so many of these lists. There's like hundreds of these list methods. And then we'll go through them, but you should do it first. That's a little bit trickier than it first seems. Yes.
Can we transfer a character to integer and plus 32?
You can do whatever works. Whatever works will work. I think everyone's identified the issue. What's the issue? What's the thing that makes this hard? It's not for looping. It's not walking through the string. It's what? How do you convert from a lowercase character to an uppercase character? What's a quick and dirty way of doing it? I can think of at least one hacky way of doing it immediately. Don't we have dictionaries? Can't you do key value pairings? Little a goes to big A, little b goes to big B. That's one. You could do that. Nothing wrong with that. But there's a better way. But on an exam, that would work. That's what I would do. Right? Couple more minutes and we'll do it together. Yes, miss. Which software? Idle, if you want. Oh, I code on VS Code. Yeah. But I don't necessarily recommend it. Yeah. Okay, I think you guys have. Okay, I'm gonna hit play. Let's have a class discussion. So I wanted to do this just basically to demonstrate apparel. Like you may look at something and it may seem easy, right? But when you actually try to do it, it may be a little bit harder. So this is something I want you to keep in mind in preparing for your intersemester. That things that look innocent may be a little bit harder if you're not sort of well practiced with the details. So please don't try. This is the wrong way for studying for the intersemester. Trying to find pre-existing solutions and studying the solutions. That's not going to imbue the ability to program. It's not the same. Reading code and understanding how it works is important, and that's code synthesis. And we are going to test you on code synthesis. But writing code, code production is also quite important, and you won't learn how to produce code by just reading other people's code. You sort of have to stew in confusion a bit. Have you ever heard this aphorism? Confusion is the sweat of learning, right? If you're confused, that's kind of good. I don't want you to be confused a lot, right? But it is sort of a evident of your struggle, right? If you're at the gym and you're not sweating, why are you sort of at the gym? Okay. So I think the problem here is the fact that we don't know how to capitalize a letter, right? So if I gave you this, if we were wish list programming, let's think about it this way. Okay, so def capitalize, C's, string. Return a string. Okay. Return C's with all lowercase letters, capitals, okay? And I could have something like, I think I capitalize, AAA, right? That should return something like AAA, and capitalize X space 1 space Y space asterisk should return something. That's this, okay. So the wish list programming would sort of go like this. I want to accumulate on the empty string. I want to return that eventually. I want to look at every character in this string. And I want to say something like, well, it depends how we implement. Okay, so I can say if C is a lowercase letter, so if it's between here, okay, Z, then it has to be, I need to accumulate, and I need to intervene into the accumulation by converting this to cap. Well, let's say make capital, right? That letter. And else, we don't really need to do anything but accumulate. If make cap capitalize that letter, would this work? Okay, therefore, the issue isn't really the capitalized routine, but the specific task of making one thing a capital. So this is important for two reasons, right? This is how you're sort of working with abstractions. Like you need to sort of, you don't want to do too much at once. This is a good starting place. Beginner programs have a tendency of trying to build things bottom up. You don't do that. You have to go top down, right? You have a general idea of how things need to be solved. You have a general idea of what details eventually have to be sorted out, and you just sort of fill in the details top down. Okay, so here's my top level algorithm. Right, and I can say, okay, this will probably work if make capital is working. Okay, so I can say def define make capital. Okay, C, it's a string. I return a string. I say something like return the capital version of C. Okay, and it's something like make cap A gives you uppercase A, and make cap on 1 doesn't do anything, and make cap on capital Z doesn't do anything. Any preconditions necessary for this function? What precondition have I put in every function that we were working under the assumption that something was a character? Pardon me? Yeah, we have to ensure that the thing that was given to us only is like length 1, because this is a string. There's no such thing in Python as being given a character. Okay. You're on an exam. You're like super stressed out. You just need to get a correct answer on the page. Here's a totally acceptable answer to this question, right? A goes to A, B goes to B, so on and so forth. And then you just sort of like key index out. That will work. It will work. And it's fine. That would be acceptable on an exam. This would not be acceptable, I think, in your written, like in your programming, right? Because something more clever is required here. Okay, so we talked about strings, and I said, don't get overwhelmed necessarily, because I haven't given you many tools, like maybe half a dozen tools. And one of the tools we have on strings is the fact that strings have order, Okay, and I can go from order to string, and I can go from number back to string. Okay, so given that all of the letters are organized in the ASCII table, and the capital letters are there, and the uppercase characters are there, what do I have to do? Yes. 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 Great answer. Okay. So I'll phrase that a little bit different. There's a duck for you if you want. We need to figure out where a lowercase a is in the alphabet, right? If I know where lowercase a is in the alphabet, then I can just basically like I can say something like, take a look at this. I know what the order, I can ask for the order of uppercase A, and I can convert that back, right? What will this is the identity operation, right? That's just going to give me back A. Well, if I add numbers to this, right, you're going to start going down the alphabet. So how do I know where is A ordered in the alphabet? Well, um, so I take the order of A and I subtract the order of A. Where's A in the alphabet? It's the 0th member of the alphabet. Well, what happens if I change this to like F? Well, F is correspondingly a little bit further down the alphabet. We should start at the lowercase a and move that many spaces down the ASCII table. So how can we write a function that will return the uppercase version of a letter is just by putting X in here. And I think actually I missed a precondition here. I probably should insist that this letter is between A and Z. Okay? So look, make capital A. Yes, exactly as I wanted. What have I done? Oh, C, not C, not X. Make capital A, make capital B, make capital C. Okay, so make capital is now seemingly working. So capitalize should now be working. Capitalize. Boom goes the dynamite. Which is a meme before you guys were even born, probably. But there you go. Isn't that clever? So this is programming in essence. It's using the limited set of tools in creative ways to accomplish the goals that we want. And the thing that you need to be bolstered by is the fact that I said the tools that you're given are wholly adequate to do all of computer science. So at no point should you think, well, I don't want you to program by searching Google for how do I capitalize the letter. You're going to learn nothing by doing that. Right? You have to have some practice organizing these tools that we gave you. Okay, so I didn't give you a break, which I never do. So technically speaking, I can let you go, or we can do more examples. Which one do you want? I'm willing to lecture for a bonus 10 minutes, which the cumulative effect of that is you get one extra lecture over the course of the term. So what's chat saying? Go to hell? More examples. Okay. Is there a duck emoji? Duck? There you go. Quack. Okay, there you go. That's how I can give ducks to the chat. Okay, let's do more. Okay, I'll do one more you can pick. I can do list transpose or matrix transpose. That's one option. We can do the Caesar cipher. That is when you take, you do Caesar cipher because that's pretty much the same thing as we just did. It's just a little bit more sophisticated. Does everyone know what the Caesar cipher is? So imagine the alphabet in a circle. Imagine the alphabet in an inner circle, and then rotate the inner circle, and that's a cipher, right? So if I rotate that circle by 3, A can go to like C, B goes to D, and so on and so forth. Except that you have to sort of rotate in negative directions as well. Okay, so I'll leave that one with you. Write a function that merges two dictionaries. Actually, this one, for reasons that have nothing to do with the intersemester. It has nothing to do with it. I'm just doing this for the sake of it. We should pay attention to this example. It may have payout. Okay. So what I want to do is a reverse lookup in a table. So we know tables go from keys to values. What happens if I want to swap that? I want to go from values to keys. What's the first thing that becomes relevant here? Can I just go into this dictionary and invert keys and values? We're shaking your head over there, miss. Why are you shaking your head? The values don't, oh, yes, first of all, the values don't have to be mutable, but even if they're immutable, there's still a problem. Keys have to be distinct. Do values have to be distinct? No, everything can map to one. If I reverse that one, what does one map to? Okay, so there's two problems here. So I want to do a reverse lookup. So the preconditions is that the values in this dictionary have to be immutable because I need to make them keys. But the other thing is we're not going to be able to go to single values. We're going to have to collect lists of values now, right? So this is what we're going to do. This is a very basic pattern for dictionaries, and let's give it a try. Okay, so I'm going to do define reverse lookup. I'm going to have a dictionary, and I'm going to return a dictionary. There's not much I can say about this dictionary because they're sort of arbitrary, but I can sort of give a reverse lookup. Okay, I can say if A goes to 2 and B goes to 2 and C goes to 3, then the reverse lookup of that should return a new dictionary where 3 is going to C, but a list, right? Because there may be more than one, and where 2 is going to the list A and B. Okay, so here's what I'm going to do. Same accumulator pattern that we've been using this whole time. I'm going to start an accumulator. I'm going to make that the empty dictionary. I'm going to eventually return that empty dictionary. I'm now going to walk. So for a key in this dictionary, what do I need to do? I need to reverse. Well, so what I want to do something is like, here's the value associated with that key. I now want to go into the accumulator at this value and append the key. But it will just certainly throw a key error. Or is this fine? What's in the accumulator? Is there a value there? Okay, so this append, maybe this, if I write it like this, maybe this will make it more clear. Append is really this. And is value necessarily in the accumulator dictionary? No. Okay, so we have to, I think one of the options here was for us to use these nice new comprehensions. And I can say, sort of, okay, I have to be careful here. So I have D, I have key. I want to map that to empty list for key in D, right? So now I've just gone ahead and given default empty list values for everything, right? So this now is going to be fine. Let's see if this will work. Reverse lookup, and then we'll call it a day. Ta-da! So it may be a good idea to know how to reverse a table for your intersemester exam. Is the rumor. I don't know. But otherwise, I'll see you guys next week, which I think is my last lecture with you guys before Casper comes. Then I'll come back for the final. Oh yes, he's from MIT. He's going to be teaching you exceptionally well. I'm quite keen to have him. So see you guys. Start your assessment. At least download it and read through that specification so it can be in your head. There was one person in the help center. Come collect your ducks or stickers if you prefer. See you guys later. Bye, chat.